In this lesson, we are going to learn how to calculate standard formation of a few things. First of all, we are going to look for the standard formation of entropy, and then we have enthalpy, and then we have Gibbs free energy. And notice how the term standard is represented by that superscript, okay? Superscript of look like a circle or a letter O. Now the word standard represented by this superscript letter O is not referring to the STP standard temperature and pressure that we are dealing with when we're working with the gas law, where we have 0 Celsius and pressure 1 atm. The only difference that this standard from this STP is that look at the temperature. It's not at 0 Celsius, but it is rather at 25 degrees Celsius. That is a very comfortable temperature. Where STP right here, this is referring to the 0 degrees Celsius. That's freezing. That's really cold. But the pressure is the same thing, 1 atm. And when we talk about solution, we're talking about 1 molar or 1 molarity of that solution. So let's look at the equation as a whole and how are they relate to each other. Notice how they all have the same or very much similar format. We can call it the same format. That is, it's always relative to this right here, delta. What is delta again? Remember, delta is changes, right? So what does changes mean? Well, in chemical reaction wise, changes always refer to product minus reactant. Or we can think of final minus initial. So all of them are looking for the changes in terms of delta S, delta H, and delta G. And look at the little circle on top, that superscript that tells you are calculating at standards. In this case, standard entropy, standard enthalpy, and standard free Gibbs energy. And the equation is pretty much the same thing. You take the sum of the product minus the sum of reactant for all of them, except for one thing that's different, is that for delta H and delta G, for any element, most likely like pure elements, for instance, let's say I have sodium as a metal form, we would know that the delta H formation for Na would be 0, or O2 would be 0, or something as simple as, how about hydrogen? It's a common one, okay? So notice that would tell us that those delta G or delta H formation, those will be equal to 0. And sometimes they are not given to us, so we have to know that's equal to 0. But before we try to solve one of this problem, we need to realize how it is related to the whole entire thing, specifically to heat. Well, first of all, heat is represented by Q, right? And we learned that Q equal to heat and is also equal to delta H, which is the enthalpy, which is the content in the system. And delta H means the changes in the content system. So heat is a transfer of energy, which is equal to the changes in the energy in the system. Now we also learn that negative Q, that means we are losing or the system is releasing heat. So we can make a relationship, hey, if I have negative Q or negative heat, therefore I must have negative delta H. So negative delta H and negative Q releasing heat. And we know that the word releasing heat or releasing energy, that is also referring to the exothermic reaction. Now exothermics, this right here is heat, okay, or energy. Exo means exit. So you exiting the heat reaction, so you are releasing. So right away, when I give you exothermic reaction, you have to know that it is negative delta H and negative Q. Let's look at the opposite, where we have positive Q. We will, of course, let's look at the opposite when we have positive Q, and positive Q equal to positive delta H. And instead of releasing heat in terms of exothermic, we have endothermics, okay? Endo is for enter, so the heat is entered the system or chemical reaction. So endothermics. When you see endothermics, you will know right away is positive delta H and positive Q. Well, in this case, we have the delta G naught. What does that tell you? So we can actually relate that to the delta G naught if we have positive delta G naught, okay? Or standard changes in G. If we have positive delta G naught, that tells you, just like in electrochemistry, it is a non-spontaneous reaction. Where if we have a negative delta G naught, okay, when we have negative delta G naught, okay, this tells you that the reaction is spontaneous. So by looking at the changes in G, we know if the reaction is spontaneous or not spontaneous.